Now we shall deal with the third aspect of permutations, and that is formation of numbers. You will be given certain digits. For example, let me say 1, 2, 3, 4 and 5, and you will get questions like how many 3-digit numbers can be formed by using these 5 digits. From these 5 digits, how many 3-digit numbers can be formed? And in this again you have 2 categories, one which says that the digits cannot be repeated, and the other category is digits can be repeated. So whenever you get a number problem, first check for the statement whether this statement is there. Digits cannot be repeated, or if nothing is mentioned, please note this, if nothing is mentioned, then we take it as digits can be repeated. If digits cannot be repeated, it will be specifically mentioned in the question. Most of the problems in our syllabus are dealing with problems based where digits cannot be repeated. Now, let me take an example. If I am asked to find 3-digit numbers using these, so one way is from these 5, I have to choose which 3, and then I need to arrange also, because if I take 1, 2 and 3, and 3, 1 and 2, even though they are the same 3 digits, when I change their order, the number changes. So that is why it belongs to the category of permutations. And then I could say the formula is from 5 choose 3 and arrange 3, so it is 5p3. But when we get problems based on numbers, not all questions will be as simple and beautiful as this one. You would also get questions with some conditions, with some restrictions. When we are dealing with number problems and conditions and restrictions, it is better to do it in a different way. If I were to repeat the same question, how many 3-digit numbers can be formed using these digits 1, 2, 3, 4, 5, where digits cannot be repeated? I will do this in this method. I will fill each place one by one. So here this is units place, and in this units place I can fill any one of the 5 numbers. This is the tens place, I can fill any one of the 5. This is the hundreds place. Here also I can fill any one of the 5. There is no restriction on any place. So I can start filling any place first. So I'll start from here. The first number has 5 choices. And the next one, I cannot repeat the digits. One number has gone here. So from the remaining 4, I can pick any number here. So this place has only 4 choices. Now come to the next one. Here I have filled one number, here I have filled one number. 2 numbers are gone. So for the last place, I have only 3 choices. So it is 3. So the total number of 3-digit numbers is 5 into 4 into 3, and that is 16, which is same as 5p3. So you notice here that you could use both the logics. Now, if there is a question with some restriction or condition, supposing the question is how many 3-digit odd numbers can be formed? And again we stick to digits cannot be repeated. There is a restriction. Now where is the restriction? The restriction is for the units place. When it is an odd number, this place you can have only 1, 3 or 5. So the units place can be filled only with 1, 3 or 5. So this place has only 3 choices. Whichever place has a restriction, fill that place first. So here I have filled with one of the 3 digits, and now let me come back here. Out of 1, 3 and 5, at a time only one number can be filled here. So one number is gone. The other 2 digits are available, they can be filled here also. So let me say 1 is gone. How many digits are remaining? 4 digits are remaining. And then now 2 places are filled, 2 2 numbers are gone, how many are remaining? 3 are remaining. So this is 3. So the total number of odd numbers is 4 into 3 into 3, and that is 36. Whenever there is restrictions, it is better to use this method, filling each place one by one. Wherever there is a restriction, fill that place first. So when we are dealing with number problems, we will stick to this method of calculation instead of going for the permutation formula. Question 1. How many 4-digit numbers can be formed using the digits 1, 2, 4, 5, 7, 8 and 9, no digit being repeated in any number? So the question says, how many 4-digit numbers can be formed? So let us say there are 4 places to be filled. Now there is no restriction on any place, so I can start from anywhere. Let me start from here. Totally I have how many options? Please count. 1, 2, 3, 4, 5, 6 and 7 options. So the first place can be filled in 7 ways. The next second place can be filled. 1 number is gone, so you can fill it in 6 ways. And now 2 numbers are gone. The next one can be filled in 5 ways. And now 3 numbers are gone, and the next place can be filled in 4 ways. So the total numbers is, so the total 4-digit numbers is 7 into 6 into 5 into 4, which is equal to 840. Question 2. How many 4-digit even numbers can be formed from the digits 1, 2, 3, 4, 5 and 6, and digits cannot be repeated? 4-digit, please note it is 4-digit and even numbers. So when I say even numbers, there is a restriction. What is that restriction? The last digit has to be an even number. How many even numbers are there in our list here? So either it can be 2, or it can be 4, or it can be 6. So this place had a restriction, so I'm filling this place first. I have 3 ways of filling the units place, so this can be filled in 3 ways. The other places do not have restriction, so I can fill it in any order. Out of the 3 numbers, 1 number is gone for this place. Let us say 2 is gone. Now how many are remaining? 1, 2, 3, 4 and 5. So this place can be filled in 5 ways. Now 2 numbers are gone. If 2 numbers are gone, then I have how many choices or how many ways I can fill this in? 4 ways. 3 numbers are gone, so now the remaining place can be filled in 3 ways. So the total numbers is 5 into 4 into 3 into 3, and that is 180. Question 3. How many 5-digit numbers can be formed with the digits 2, 3, 5, 7 and 9, which are, and we are given 4 sub-questions. A, less than 30,000, B, greater than 70,000, C, between 50,000 and 90,000, and D, greater than 75,000. So we are asked to find 5-digit numbers, and at the end it says digits cannot be repeated. 5-digit numbers. Now I'll come to question A. Question A says it should be less than 30,000. If a number should be less than 30,000, where is the restriction? We obviously know there is a restriction, but where is the restriction? 5-digit number. The restriction is here in the first place. If it has to be less than 30,000, from here, which are the numbers I can place in the first one? If I put 2, the number will be in 20,000 series. So it will be less than 30,000. If I put 3 here, the number will surely be more than 30,000. That means I have a restriction for this place, and in this place I can put only one number. Don't get confused, the number is 2 but the choice is 1. So there is only one choice for this place, so this can be filled in only one way. After this, I don't have any restrictions this side, and then how many ways can I fill here? 2 is gone, I have 4 choices, so this can be filled in 4 ways. One number is gone here, and then I have 3 choices. So another number is gone, and so remaining are 2 choices, and 4 numbers are gone, and remaining is only 1 choice. So here the total numbers is 4 into 3 into 2 into 1, which is equal to 24. Option B. In option B it says the number should be greater than 70,000. If the number should be greater than 70,000, again let us look at the restriction. It has to be a 5-digit number. It has to be greater than 70,000. Can I place 2, 3, 5? No, I cannot place. What about 7? If I place 7 here and one of the other digits, surely the number will be more than 70,000. That means I can place 7 here. 9, obviously we can place 9 also. So there is a restriction for this place, and the first place can be filled in 2 ways. So here I put 2 ways, and then one number is gone out of 7 and 9. Let us say 9 is gone. How many are remaining? And then remaining choices here is 4. One more number is gone, so 2 numbers gone, so next is 3, and next is 2, and next is 1. So the total numbers is 2 into 4 into 3 into 2 into 1, which is equal to 48. Option C. Option C says how many 5-digit numbers can be formed between 50,000 and 90,000. Again we go back to the same logic, because it is 5-digit number, there is a restriction. Where is the restriction? The restriction is in the first place. If it has to be between 50,000 and 90,000, more than 50,000 but less than 90,000. So more than 50,000, I cannot put 2, I cannot put 3, but I can put 5 here. I can put 7 because it will come in 70,000 series. Can I put 9? I cannot put 9 because the number will become more than 90,000. So the restriction here is this has only 2 choices. Now once I have 2 choices for this one, the rest of them do not have any restrictions. So one number is gone, let me say 5 is gone. How many are remaining? 4 are remaining. So this is 4, and then 2 numbers are gone, 3, 2 and 1. So the total numbers is 2 into 4 into 3 into 2 into 1, which is equal to 48. How many 5-digit numbers can be formed which are greater than 75,000? So please note here it is 75,000. Again it is a 5-digit number. Digits cannot be repeated. 75,000 means where is the restriction? You surely know there is a restriction here. If the number has to be greater than 75,000, I cannot put 2, 3 and 5. I can put 7, I can put 9. Now look at this sum carefully. When I put 9 here, all the numbers beginning with 9 will be in 90,000 series. So they are surely greater than 75,000. So when I put 9 here, I don't have any restriction on the remaining digits. But what about 7? When I put 7 here, if the number has to be greater than 75,000, then there is a restriction for the next place. I cannot put 2 because it will come in 72,000 series. I cannot put 3 because it will come in 73,000, but I can put 5, I can put 9 also. So that means now, when I put 7, there is a restriction here. When I put 9, there is no restriction here. I cannot do it together. I need to calculate it separately. So that is why I will do the two cases separately. So let us take case 1. Case 1 is when the first digit is 7. If the first digit is 7, this can be filled only in one way. If it has to be more than 75,000, I cannot put 2, I cannot put 3. I can put 5, 7 or 9, but 7 is already there here and I cannot repeat the digits. That is why I cannot put 7 here. So the choices I have for this place is 5 and 9. So this had a restriction and this had a restriction. This can be filled in two ways. Now the other three places do not have any restriction. Two numbers are gone. Remaining is 3 and then 2 and then 1. So the total number here is, so this is total numbers. When the first digit is 7 is 2 into 3 into 2, and that is 12. This is case 1. Now let us see what is case 2. Case 2 is when the first digit is 9. When the first digit is 9, this restriction, this can be filled only in one way. What about the remaining 4 places? They don't have any restriction. 9 is gone, 4 numbers are remaining, same logic, 4, 3, 2 and 1. So here you get the total numbers is equal to 4 into 3 into 2 into 1, which is equal to 24. Now I am interested in the total numbers which are greater than 75,000. These also are greater than 75,000. These also are greater than 75,000. Either the first case or the second case, that whenever it is or, you have to add. So total numbers greater than 75,000 will be 12 plus 24, which is equal to 36. Question 4. How many 4-digit numbers can be formed using the digits 0, 1, 2, 3, 4, 5 and 6? Digits cannot be repeated. And question A, how many of them are odd? And question B, how many of them are divisible by 5? Please note here, there are 3 questions. First one is, how many 4-digit numbers can be formed? Now, first question is, how many 4-digit numbers can be formed? Is there any restriction given? So when you look at it, it looks like there is no restriction given, so we can directly go for the logic that we have done before. But before you assume that, look at the digits given. You notice that there is a 0. When 0 is there, restriction is always there. What is that restriction? If I have to write a 4-digit number, I cannot put 0 in the first place. If I put 0 in the first place and write this as an arrangement, this becomes a 3-digit number and not a 4-digit number. So when 0 is there, restriction is automatically there. So we shall now calculate with the restriction how to calculate 4-digit numbers. So we go for the same logic, 1, 2, 3, 4 places. The restriction here is this cannot be 0. You can fill it with any number except 0. So since I cannot put 0 here, the first place I can fill it in only 6 ways. So the total ways of filling the first place is 6. Now come to the second place. I have already filled one number here. It could be any one of them. Let me say I filled 1. So 1 is gone. When I come to the second place, I don't have that restriction of 0. The second place can be filled with 0. But because digits cannot be repeated, I cannot fill it with the number that I have put here. So that number is gone. And how many numbers are remaining? How many numbers are remaining? Again, it is 6 numbers. One number is gone and another is included. So again, it becomes 6. Now, 2 numbers are gone. How many numbers are remaining? Remaining is 5. And now 3 numbers are gone and remaining is 4. So the total numbers is 6 into 6 into 5 into 4, and that is equal to 720. Option A. How many of them are odd? The question is, how many of them are odd? And they are again 4-digit numbers. So 1, 2, 3 and 4. What is the restriction now? 0 is there. Automatically there is a restriction, and that is this cannot be 0. There is one more restriction. What is that? I want it to be odd number. And if it has to be an odd number, then the last digit can be only 1, 3 and 5. I have told you, whichever has restriction, fill that place first. Now, there are 2 places with restriction. Does it make a difference with the start with the first or the second? Or does it make a difference or does it not make a difference? It will make a difference. Probably you'll be able to do it both ways, but the methods will be different. Sometimes you may get more cases. Let us just look at this again. If I start filling this place first, what happens? Supposing I fill this place first, my only condition is I cannot put 0. I can put odd numbers or even numbers. Supposing I fill this with 1, then when I come here, since 1 is already gone here, I will have only 2 choices for this place. So if I fill this with 1, this will have 2 choices. But supposing I fill it with the even number, supposing I fill it with 2. If I fill this place with 2, then this place I have 1, 3 and 5. So here when it is 1, my choices were only 3 and 5. But when it is 2, it can be 1, 3 and 5. So it makes a difference. So I should take 2 separate cases. Can I avoid this taking cases? You can do it like this, fine, perfectly fine. But let me try to avoid these cases. So instead of starting from here, if I start from here, then I will get the sum in only one case. So it is better to start from here. So now I am going to fill this place first. And here, how many ways can I fill this place? Because it has to be an odd number, it can be filled with 1, 3 or 5. And this can be done in 3 ways. Now come to this place. Out of 1, 3 and 5, one number has gone. Let me say 1. And now I cannot put 0. So 2 numbers restriction. So these 2 I cannot put. So how many choices I have? I now have 5 choices. When I come to fill this place, there is no restriction. I have finished filling 2 places. So 2 numbers are gone. Any 2 numbers are gone. How many are remaining? 1, 2, 3, 4, 5. Again it is 5. And then this place it is 4. Total numbers is equal to 5 into 5 into 4 into 3. And that is equal to 300. Option B, how many 4-digit numbers are divisible by 5? When do we say a number is divisible by 5? When the last digit is 5 or 0. So let us see where are the restrictions. 0 is there, automatic restriction, this cannot be 0. Also, divisible by 5, this can be 5 or 0. Now look at this sum. Again, it has two restrictions. Where should I start? From our previous experience, we will not start from here, we will start from here. But please notice here, observe, the restriction is involving the number 0, and here also the restriction is based on the same number. In the previous example, it was 0 here and 135 here. The numbers were independent. That means probably we will have to go for two cases, because if I put 5 here, let me say I put here 5, then what are the numbers I can put here? I cannot put 5 because it's already gone. Because it is first place, I cannot put 0, and that means I will have 5 choices. But if I put 0 here, what happens when I put 0 here? If I put 0 here, the 0 is already gone. So this restriction is gone. If 0 is gone, I can put any one of the 6 numbers. Then here I will have 6 choices. So we notice, if it is 5, there will be 5 choices. But if it is 0, there will be 6 choices. Number of choices for each one is different. I cannot do it together. I have to go for case 1 and case 2. Now case 1, last digit is 5. When the last digit is 5, this can be filled only in one way. This cannot be 0. This cannot be 0, and 5 is gone. So my number of choices is 5 choices. After this, 2 numbers are gone. So if 2 numbers are gone, let me say these 2 numbers are gone, and how many are remaining? Again it is 5, and then the next one has 4 choices. So the total numbers that I am getting here is 5 into 5 into 4, which is equal to 100. This is case 1. Now let us see case 2. Case 2 is when the last digit is 0. Again we are dealing with 4-digit numbers. Here the last digit is 0. This can be filled in only one way, and if this is 0, now the first place can be filled. How many choices? I can fill any one of the 6 because 0 is already gone. So this can be filled in 6 ways. Now 2 numbers are gone. Next it can be filled in 5 ways and then in 4 ways. So here the total numbers that I get is 6 into 5 into 4, which is equal to 120. And the total numbers divisible by 5 are add the 2. Total numbers divisible by 5, 100 plus 120, which is equal to 220. Question 5. How many 3-digit numbers can be formed using the digits 1, 2, 5, 6 and 8? Read this question carefully. It does not say anything about digits can be repeated or cannot be repeated. If nothing is mentioned, we assume that it is understood that we can repeat the digits. So then, how do we work out this sum? I am asked to find a 3-digit number and I can repeat the digits. When I fill the first place, there is no other restriction here. When I fill the first place, how many choices do you have? I can fill it with any one of the 5 digits. So I have 5 choices. Now come to the second place. I can repeat the digits, so again I can fill it with any one of the 5. I don't have any restrictions of not repeating. So the next one also has 5. And what about the third place? Again, since I can repeat the digits, I can use any one of the 5, and this also has 5 choices, and therefore the total numbers is equal to 5 into 5 into 5, and that is 125. Note this sum. Because it was not mentioned, digits cannot be repeated, we have used the logic where we could repeat the digits. Question number 6. How many 6-digit numbers can be formed with the digits 2, 7, 6, 1, 9 and 8? Digits cannot be repeated. Fine. 6-digit numbers 1, 2, 3, 4, 5 and 6. No other restriction except that the digits cannot be repeated. Fill it in any order. The first one has how many choices? Count. There are totally 6 digits. So the first one has 6 choices and the next one has 5, 4, 3, 2 and 1. So this one is, therefore the total numbers is 6 into 5 into 4 into 3 into 2 into 1. You would have directly done it as 6p6 also, which is 6 factorial, which is equal to 720. Question 7. How many 3-digit numbers ending with 7 can be formed using the digits 1, 2, 5, 7 and 8, and digits cannot be repeated? So I have to form 3-digit numbers 1, 2 and 3. What is the restriction? The number should end with 7. So this number is fixed here. This has to be filled with 7 and this can be done in only one way. Since the digits cannot be repeated, 7 is gone and I am left with 4 numbers. So this one has 4 choices and this one has 3 choices, and therefore the total numbers is 4 into 3, which is equal to 12. Question 8. How many 6-digit numbers can be formed with the digits 1, 2, 3, 4, 5 and 6? No digits can be repeated, which are divisible by 5. 6-digit numbers which are divisible by 5. 1, 2, 3, 4, 5, 6. Divisible by 5 means the number should end with 5 or 0. Luckily for you, 0 is not there here. So the only option is the number should end with 5. So there's a restriction here and this can be done in only one way. So this is filled in only one way and there is no restriction for the other places. 5 is gone and you're left with 5 numbers. So here it is 5, 4, 3, 2 and 1. So the total numbers is 5 into 4 into 3 into 2 into 1, which is equal to 120. Question 9. How many 4-digit numbers can be formed with 0, 2, 3, 5 and 7 such that no digits are repeated? So you have to form 4-digit numbers, no restriction, but 0 is there. Automatically there is a restriction. And what is that restriction? The first place cannot be filled with 0. If this cannot be 0, then I have how many choices? 1, 2, 3, 4 choices. Out of the 4 I can fill it with any one number. Let me say I fill it with 2. When I come to the next one, I can fill 0 again. So I have 4 choices. Now 2 numbers are gone, next is 3 choices and then is 2 choices. So the total numbers is 4 into 4 into 3 into 2, which is equal to 96. Question 10. How many numbers between 300 and 3000 can be formed with the digits 0, 1, 2, 3, 4 and 5? Read this question carefully. One is, it says between 300 and 3000. So 300 and 3000 is not included. It does not say anything about digits cannot be repeated. That means we can repeat the digits. It does not even tell you how many digits. Now, till now you had all the question where it said 3 digit, 4 digit, 5 digit. But this is not telling you, but I think you will be able to understand if the numbers have to be between 300 and 3000, they could be 3 digit or they could be 4 digits. So I know now that I have to take two cases, how many 3 digit numbers can be formed and how many 4 digit numbers can be formed. So let us take case 1. Case 1 is 3 digit numbers. One, 2 and 3. So 0, let us fill it from the first one. In the first place, I cannot put 0. If the number has to be between 300 and 3000, it has to be greater than 300. So 0 I cannot put 1 also. I cannot put 2 also, but I can put 3. So I can put 3, I can put 4 and I can put 5. So how many choices do I have? I have 3 choices. Now, after this, come to the next one. This one, I can fill it with any one of these 6 numbers because I can repeat the digits. So this has 6 choices and this also has 6 choices. So the 3 digit numbers, so how many 3 digit numbers are we getting? 3 into 6 into 6, which is equal to 108. Now let us see case 2. Case 2, 4 digit numbers. First place, now what is the condition? It should be between 300 and 3000. Now if it has to be between 300 and 3000, it should be less than 3000. 0 obviously I cannot put. I can put 1, I can put 2. Can I put 3? Cannot put 3 because the number will become more than 3000. So the only choices I have is 1 and 2. So this can be filled in 2 ways. The other 3 have no restrictions, so I can fill it 6, 6 and 6 ways. So the total 4 digit numbers is 2 into 6 into 6 into 6, which is equal to 432. And next what you would do is, we will add the 2 numbers. When I add the 2 numbers, so the total will be 108 plus 432, which will give me 540. Before you conclude that 540 is the answer, think again. Just do some verification. One is here digits can be repeated, and the other one is it says between 300 and 3000. Just take care to see that you have not included 300 and 3000 in your calculation. Come to this one, I have not put 3 at all here. So 100% sure that 3000 is not included. Now come to this case, I have put a 3. Will one of these 108 numbers be 300? Just check. I can put 3 here. So one case is when I put 3 here. Here I could put any one of the 6 numbers. So one case is when I put 0 here. And another case, again I could put 0 here. So there is 300 included in the list of 108. That means I have included 300, so what should I do? I should exclude that one number. So since 300 is included, total numbers is 540 minus 1, that is 539. You could have also subtracted 1 here itself and made this 107. So that also was possible, but I just kept it for the last for you. So before you conclude, just take care to check whether these two are included or not included, because when it says between, the two end numbers should not be included.